Yes, Eva. Can you see the screen? Now, request to you if you are okay. Can I record this meeting for my reference? Like how I am
Yeah,
teaching? Okay, fine. Just for me, like how I'm teaching, how I'm taking the class, it will help me in that way. Okay, so write it down. Draw this picture and this part. Write it down.
just give me a second.
Sure.
Yes, I'm done.
Okay. Now next, let us see how does the refraction takes place. Okay, see here, Eva, I will explain myself and then we will see what is written there. You will have to see here, Eva, then I can explain.
Yes. Yes.
Okay, again the example of air and no, this time not water. Glass is taken. Okay, yeah, any type of glass. Uh, any simple glass in which we keep water also, that is also fine to understand this. Now this is the incident ray. Okay, like from anywhere, if this glass is kept in the room, then the light from the bulb or the LED being coming, or in sunlight, then the sunlight is the incident ray here. This is the
Yes.
normal, this is the main thing, like thing which I haven't explained you properly yet. Normal is a straight line which forms 90-degree angle with the surface. Always remember. So this is normal. So when incident ray just hits this normal, just imagine the normal being placed there and hits
Yes.
it, then it gets refracted in any direction. Here it is just shown little bit refraction means little bit bending. Refraction means bending of light like this. And what is angle of incidence? This is angle of incidence which is being formed. This is angle of refraction or refracted ray. Sorry, refracted ray is this, and this is angle of refraction. This is denoted by I, this is denoted by R. Okay, angle of incidence I, angle of reflection R. Clear?
Yes. Yes.
Now let us see what are they writing above. Refraction occurs when a ray of light travels from one medium to another. The ray of light may change direction. Refraction happens at the boundary between the two materials. The ray approaching the boundary is called the incident ray, and the ray leaving the boundary is called the refracted ray. The angle of incidence I and the angle of refraction R are measured to the normal. Measured to the normal means with reference to the normal, how much angle it is making with the normal. Drawn at the point where the ray hits the boundary.
Yeah.
Now draw the picture first, then you will have to write all these things. First draw the picture, and this is very important. So not a rough picture, a clear picture you have to make. If possible, I will suggest you to use your scale, okay, or ruler.
Mhm. Yes, I wrote it.
Okay, now the explanation part. Hmm. Everything, almost everything. Write it. Done, Eva?
Yes. Almost, miss. Yeah. Now I'm done. Yes.
Yes, Eva.
Yeah, I finished now.
Okay. Now, experimental skills. See, um, this is the main experiment you would be going to do definitely in your school. Okay, it's like passing the
Mm-hmm.
ray of light from any glass. How does the ray of light changes the direction when it enters? Well, like when change in medium takes place from 1 to 2 and then back to 1 again. That is explained here.
Okay.
Okay, but first let us go what is being said here. Investigation refraction. If I will feel it to be important, I will take, otherwise I will just explain and leave it. Investigation
Okay.
refraction. You can investigate refraction by shining a ray of light into a glass or perspex block and tracing the path of the ray. Ray box, power pack, regular glass or perspex block glass or perspex. This is the same ray hitting the glass. For I cannot find anything else. Let us see. Um, Getting started. Pins, optical pins to place. Um, yeah, pins to place the. You will place the pins where the ray of light will go. That is the task of the optical pins. Let me tell you, Eva, this is very old experiment. Even I have done in my school in my time when I was of your age. So this
Mm-hmm.
is important, of course. Um, Now getting started, how will you mark the path of the rays going in and out of the block? How will you determine the path of the ray inside the glass block? Place the block on paper and draw around it. Shine a ray into the block as shown in the figure. Mark the ray going into uh, the same thing. What are they writing here, Eva? You have to, you can do either, like it depends upon what type of glass your school is providing you. This is a rectangular glass slab. Okay, either in place of it, you can go with a prism even, or this type of lens. Investigate the refraction of light as it passes through different shaped blocks, such as this. So with different shaped mirror or the lens, you can say, or the object, how the ray gets change. That is being said to do in the experiment. Measure the angle of incidence, angle of refraction, and like this is the whole task to do. This is not a practical class ever, so I am not covering these steps. I hope it's fine, right?
Yeah.
So when you will do in your school, they will tell you in detail. Leave this part. We will do this one directly. The theoretical explanation. Changing direction. Figure 13.17 shows light passing through a rectangular block. Block or slab is the same thing. Fine. A slab is little bit thick. This is a block. I think this would be thinner. Notice that the light only bends at the point where it enters or leaves the block. So as I told you, when the medium is changing, then only the refraction will take place. In the same medium, definitely refraction doesn't take place. So it is the change of material that causes the bending. Clear, change of medium, change of the material. Next, they explained in detail, and that is very good. Demonstration of the refraction of a ray of light when it passes through a rectangular block of glass of perspex. The ray bends as it enters the block. As it leaves, it bends back to its original direction. So can you see that this is this direction and this direction is same because the medium is same. When the medium is changing, here the direction is changing. Little bit it is bending towards left. Clear? Now next, what are they saying? This is done. As it leaves, it bends back to its original position. From figure 13.17, you can see that the direction in which the ray bends depends on whether it's entering or leaving the glass. So its direction depends on in which medium the ray is traveling. The ray bends towards the normal. Now this is important. They have not shown it here. Let me check if any picture they are showing next. No. Then I will have to show you. See what they are trying to say. Now they are talking about the ray bends towards the normal. If this is the glass slab, this should be the normal, exactly making the 90-degree angle. Do you agree or any confusion in the normal?
No, I get it.
Okay, so this is 90-degree. So you can notice here, Eva, that the ray
Mm-hmm.
which is passing here, when it enters the second medium, that is the glass here, it moves towards the normal. Means earlier, if this glass slab would not have been here, it would have traveled or continued in this path. But now it is bending towards the normal. It is towards the left side where the normal is there in this picture. That's why it is said the ray bends towards the normal when entering the glass and when it leaves. Now, when it will leave, I am I am surprised why have they not shown it here. I will have to show you how it is taking place, like towards or away from the normal. This is the second medium, like second change, and this is the normal, second normal. Of course, this should be the 90-degree angle. So here you can see, Eva, that the ray which was traveling, the ray bends away from the normal when it travels, when it leaves the glass. So just opposite the case. Here it is moving away. Means earlier it was traveling, let us say this is the I have made little bit far. Wait, it should be here. So it is moving away. Earlier it would have traveled the blue line. See here. This is a little complicated thing which I am explaining you. This is the straight line. This is the normal. Then earlier it was traveling in this direction, but it bent, it tilted towards right. Earlier it was towards left, here it is right. This is what they are trying to explain in just 2 lines. Okay, I'm repeating. When the ray bends, first, when the ray enters the glass, then it will move towards the normal, towards. So this is the normal, this is straight line where my cursor is moving. The ray of light would have traveled in this direction. Again, where I am showing with by my cursor. But it is tilted little bit towards left. Again, when it is leaving, then opposite is the case. It will move towards right. Right means away from the normal. Just opposite is the case. You will learn better. Again, I'm saying same thing. When you will do practical now, you will learn, your teacher will explain the same thing again back practically. Okay. And there in your practicals, one more additional thing I'm telling you, the pins which are used now, you will use those pins to show the direction of the light. Like this, you will like put the pins, you will fix the pins in its position, showing that this is the path of the light. This is the use of the pins which you are going to do. Any questions?
No.
I hope everything is clear, Eva. You don't ask questions. Whatever I explain or
No, I got it.
fine, it will be clear in your test. I say the same thing to all the students because majority of them, like you, they don't ask questions. So when you will do the test, then it will be clear that time. Okay. Anyhow, now wait.
Hello.
Write the topic light passing through a rectangular block, and I will show you the like another picture in place of myself doing the work here. I will prefer to give you a proper image. Till then, write this topic.
Okay.
I got it. This is I'm searching this just the simple one so that you can understand better. Mm,
Yes. Miss, give me a second. Sorry, my brother was in the room.
no issues. I'm opening the page. I hope I got a very simple picture, but yes, of course, a good explanation from where you can draw the glass slab and the refraction of light through it. Yes, this is fine. Yes, Eva. This is the picture where the normal is also shown. Okay, the two normals.
Mm-hmm.
And this D is just the displacement of light. Like actual path was going to be this, but it got bent, and this is the displacement. Don't write D because this is not covered in your book so much in detail. You can just
Okay.
leave this D, else all you can write. And this is angle of refraction, this is angle of incidence, this is angle of refraction. Let me increase the size of the page to make it more visible to you. I hope it's clear.
Yeah,
Okay,
it is.
and yeah, angle I, angle R, only skip this D. Don't write it. Else everything, draw. Okay, and this, if you want, you can write it for your reference. This is normal. These both are
Mm-hmm.
normal. Do it.
I drew.
Okay. Now back to the page from where you have to write the description. Okay. Um, these two things, very, very important part to remember in this experiment. Okay. Write this down
Yeah.
and then
Miss, I wrote it.
Now, next thing. This thing you are going to explain. Read it carefully and then you will explain in the given picture. And what am I saying? This one. Wait. Um, one consequence of this thing is that when a ray of light through a parallel sided block of glass of perspex is just a brand, means which just has which manufactures good glass slab, you can say. That is why it is repeatedly written perspex. Don't get confused with perspex word. um, or, or perspex, it returns to its original direction to travel. When the light passes through a parallel-sided block, this is the parallel-sided block of perspex, it returns to its original direction of travel. What does it mean? Although it is shifted to one side. I explained you. Although it is shifted, it is in the same direction here, but it is shifted. What does it mean? Check the
Um,
you made. The answer is given there in that picture.
um, um, um,
This. See, this is the original path, Eva. It would have traveled, but if it would have been in the same but medium. But here, when the medium is changing the place, then this is the displacement or